Hi, this is Fred Jellybean, Chapter 5, page 37, just as a note on your paper. And it is 5:30, and if you remember, we have been talking about that Fred had the math and pizza conference, and everybody was leaving to go home. Everybody thanked, if you remember, Elaine Marie for presenting the best math and pizza conference they'd ever attended. Darlene and Joe had left, and now Joe was like wanting an after pizza snack. You'd think after eating all the pizzas that were out there that Fred's friend Joe wouldn't want anymore. But anyhow, he wanted an after pizza snack. Betty and Alexander headed back to their apartments because they each had reading to do for tomorrow's classes, and Monday was coming quickly. So Stan Anthony sent the 19 pizza-making robots back to their home. He had rented the robots for 1 hour, and he now owed $114. So he wrote out a check, and he gave it to one of the robots to carry back to the robot rental place. Now, looking at this, we can try to figure out how much did each robot cost, because we have 114. That was what we got from here. That's what the total was for all the robots. There were 19 robots, and 19 is going to go into 114. Let's try 6. That is 6 times 9 is 54. Carry the 5. 6 times 1 is 6. 6 times, and then add the 5 in. So we have 114. So our answer is exactly 6. It's $6 per robot to rent it for 1 hour. Notice that we had nothing in this spot and nothing in this spot because it goes into 19 goes into 114, and so we're using all three numbers, and so we will go above the 4 there. So Fred headed outside and he began walking towards his office, and after several blocks he entered the Kittens campus at the Kittens University, and it was getting to be near twilight. And if you don't know, twilight occurs between the time when the sun sets, goes down in the evening, and when the darkness of night comes. So it's that moment where it's starting to get dark. And it was quiet, and it felt really good after being around all those people for Fred to be walking around. Even though he'd had a good time there, it had been very busy and very noisy. And so Fred came to this conclusion that life needs both times, the active, loud times and the still, silent times. And so Fred just walked and he let his mind settle down. He wasn't trying to figure out how to make honey cards. He wasn't planning on making a sanctuary for birds. He wasn't shopping for ice cream maker for 800 people. And he wasn't desperately trying to think of a 17-letter plural word, which is all things that he had done in the ice cream book and the beginning of this jelly bean book. Fred was just being, not doing. So Fred's friend Joe, who starts each morning off with watching. He turns on the radio and the television. He spends his whole day talking and eating. Joe would never notice the stars unless one of them exploded right in front of him. And he would never notice a perfect rose unless it hollered out to him. Eat me, I'm chocolate. Joe never took the long view of life, thinking about your whole life and what you want to do with it. Joe was like the cow in the field that just does all the things that cows do without giving a thought about tomorrow. Maybe, though, maybe no one knows it and this cow was saying, "Will you be my Valentine?" I doubt it, but Joe wouldn't notice even if it was. Not only does Joe fall asleep at night with the radio on and jelly beans in his mouth, but he also takes his bath in jelly beans. I don't even know how that would get him clean. Do you? Joe sat under a big tree and just wanted to sit and sort of let his mind drift away. He looked at his shoes, and his shoes made him think of the 9 tables, and he noticed something about every answer. 1 times 9 is 9. 2 times 9 equals 18. 18 is 1 plus 8 equals 9. 3 times 9 equals 27, which equals 2 plus 7 equals 9. 4 times 9 equals 36. 3 plus 6 equals 9. 5 times 9 equals 45. 4 plus 5 equals 9. 6 times 9 equals 54. 5 plus 4 equals 9. 7 times 9 equals 63, which is 6 plus 3, which is equals 9. 8 times 9 is 72, which is 7 plus 2 equals 9. And 9 times 9 equals 81, which is 8 plus 1, which equals 9. Fred also noticed something else, that when we had 2 times 9, the 1 was part of the answer. The 1 was the number before the 2. When he had 3 times 9, it has a 2 in it, which is the number before the 3. And he noticed a pattern. 3, there's a 3 in the 4 answer. 4, 5, 6, 7, 8, and 9 would be if we had 9 times 10 would show up as 90. And so that would even equal 9. All the answers equal. Every answer, 18 breaks down to 1 plus 8. 27 breaks down to 2 plus 7. So there's a pattern there. Fred thought of a lot of things sitting there. He thought of Raggy and Kingy, and he wondered whether his children someday would play with dolls. And then he realized, well, he didn't have a wife. He had never met any girl that he wanted to marry, but he was only 5 years old. So he still had a bit of time, but he kind of still wondered, who would he marry someday? And he thought about what it would be like to have a flashlight and sit under the tree that he's sitting under in complete darkness. And he thought about some of the books that he had read in a single afternoon. He read Wind in the Willows. Is that something that you have read? We need a capital W there. He also had read, big book, The Old Man and the Sea. Is that something you had read? Probably not. After he got through dreaming, he thought about math again. Multiplication and division are pairs in a term. They go together. What term would go with the union of 2 sets? Do you remember that? So if we had a cat and a dog, and we had a dog and a rat, this would be the union. So we're after the union of the cat and the dog with the dog and the rat, and it will equal a cat, a dog, and a rat. We have a cat, we have a dog, we already have the dog, so we don't need that, and a rat. Now, I might say, what is the intersection of two sets? So there I might have a cat and a dog. I have an upside down U, and I have a dog and a rat. Now here I want to know, with an intersection, what is the one common, and that's just the dog. So the intersection between the two things, cat and a dog and a rat, equals the dog because it is in both sets. So a union are those things that are in both sets, and the intersection is of two sets where the things are in both sets. So let's look at some examples because it might. So if I have Kansas, a clock, and a squiggly thing, and I want to know the intersection, and we have Nevada, happy face, and canary over here, what is the intersection? Well, there's nothing. There's no Kansas over here. There's no clock on this side. There's no squiggly thing on this side. On the other side, there's no Nevada, no happy face, or no canary. So there is nothing here. It's just empty. So let's say you had M, N, and P, and you want the intersection with, so the answer was M and P because that was what was in both of those and not the Q. Okay, so part one here is you're going to do your turn to play. So you'll have to ask me for the handout, and you're going to have 9 questions. When you've done that, then come back to the video, and I have a part 2 for you. But go do your turn to play, and then come back and watch the second part, which will be on an oak meadow. Okay, so this is Oak Meadow Lesson 20, and I just want to touch base on common fractions. You've been doing fractions in your practicing math bits, but I just want to talk about them. And so if I have 1/8, that's a common fraction. The part down here is called the denominator. Okay. The part above the line is called the numerator. Now, if I was said that you had 1 pizza, what I'm really saying is 1 as a numerator. We don't see the rest of it, what it would be, because it's just 1. So 1 is 1 over 1. If I had 1 piece and there were 8 pieces, I would have 1 over 8. If I had 3 pieces of pizza and there were 8 total, I would have 3/8. If I had 5 pieces out of 8, then I would have 5/8. And every fraction has a numerator and a denominator. Numerator and a denominator. Numerator and denominator. And you can remember denominator by thinking deep. That it's the deep one, which is going to be the bottom one. So let's talk about adding common fractions. Again, you've done this, but we're just kind of reviewing some basic things here. When we're adding them and they have the same denominator, then it's very, very simple. So if I have 3/8 plus 1/8, I can just ignore the bottom part because they are the same, and I can just add the top parts, and that would be 4/8. 2/7 over 3/7. I can just leave that the same because they match. And I add the numerators, and that would be 5/7. And if I saw something where they look like this, I can do it the same way. I can rewrite it so it's across like this, but in either case, I keep my 5s are the same, so that bottom stays the same, and I just have to add the numerators, and that would be 3/5. If I had 1/5 plus 2/5, my bottoms are the same, so I just rewrite that, and now I add the numerators, and again I have 3/5 there. I guess that's the same answer. I just showed it differently here. Okay. Okay, so you need to ask me for the Skill Practice A Lesson 20.4, and this is very simple. This won't take you any time at all because on this page all the denominators are the same. All the bottom numbers are the same, so we don't change them. So every answer will automatically have whatever that denominator is, and you're just adding the numerators. So you can do this. So do that, and then your math lesson, whatever you don't get done today, you will have to take home and do it and bring it back tomorrow, because homework now is any work that we don't get finished in class, we have to take it home. So don't forget to do that.